in that order, because if you do the opposite, as I just discovered, then all you see is their faces and not the stuff that we want to look at, which would be sad. Okay, so photos of deflections, right? With 2 batteries. Just a couple thoughts. As you're thinking about your deliverable for Tuesday, when you're going to be doing your week 8 challenge, pictures like this one that have where you can actually see the battery, right, are helpful because, again, as we talked about, right, if I annotated this, you can tell like this is the positive end of the battery right here. This is the, I'm sorry, yeah, and that's the negative end of the battery right here, and this is the positive end right here, and the negative end right there. So this is the positive end of the wire, right? Which means if you keep on going positive end, positive end, positive end, positive end, this is the positive end right here. Meanwhile, this is the negative end, so you get negative end, negative end, negative end. Hi, Aaron. And what you notice is, so your current, right, your electrons, which we write with an E like this. So your electrons are flowing, and you can see they're flowing through the south part and then leaving through the north part. So that should be a clockwise deflection. This one, on the other hand, that's a negative end. That's a positive end, right? So right now, this is like the positive end is over here, over the plus. The negative end is over the south. So again, that should be a clockwise deflection. And then, so see, like that's helpful for me to be able to like look at your orientation of your battery and be able to predict whether you're looking at the right thing. And then now I can look at this picture over here, the group 2 picture, and say, oh, I'm noticing a clockwise deflection compared to the wire. Therefore, this must be the positive end and that must be the negative end. Just because that has to work that way. Right? So this is why it becomes really important to be able to make those determinations carefully. Any questions about orientation of circuits? So you found this was your the photos for 2 batteries. Then you've got, oh, I need to stop annotating, otherwise I can't move it. This is therefore your 1 battery. And so observations. So what did you guys come up with? What did you notice? Yeah, Leila.
Something that I noticed that I think is also written on here was when there were 2 batteries, the deflection was a lot larger than just with one battery, which makes sense since a larger power source will be more powerful.
Yeah. Did you all find that? Did you all observe that? It seemed like there were people in the conversation, in the discussion board, that said that that was not something that they observed, that they had the same deflection no matter what. So more batteries, more power, right? More force to push the current harder, more current, more deflection. One person in my previous section asked the question like, what happens if we remove what happens if we remove what happens to the deflection if we remove the light bulb, right? So here's an experiment that I'd like you to do. So I want you to be really careful with this one, right? Because that will burn your battery and your wires. So just, a little bit, but not too much. So if I just do, let's see, if I just look at the deflection from, right, so if I look at the deflection on, for this wire with just 2 batteries, right, I get about 3 tick marks on my, oops, where is it? There it is, right? On my compass, I get about 3 tick marks. Each tick mark is about 5 degrees. So that's about 15 degrees. How much did you get if you only get 1 tick mark? How much deflection did you get for 1 tick mark? Did you measure it? Can you measure it? And again, it's going to depend a little bit on which light bulb you used, right? So I'm using the round light bulb. You should all be using round light bulb, but like, you know, different light bulbs were created differently, so that could actually change things a little bit. Ian, how much deflection are you getting for 1 light bulb, for 1 battery?
Wait, for the light bulb or for the compass?
For the compass. If you have 1 bulb, 1 battery, how much deflection are you getting on your compass?
Not that, wait, like the deflection as in where you put the wire down?
And then it moves, and by how much does it move?
Not by, I think it was less if I remember, but like it still moved a little bit, like maybe like, it's smaller than like a centimeter, but it still moved a little bit.
Do you have your compass? Do you have your stuff in front of your circuit in front of you? Because that would be helpful.
Circuit in front of me.
Anybody has a measurement? Yeah, Leila?
I got about 2 tick marks.
Yeah, I get about 1.5, right? 1.5 to 2 tick marks. So 7 to 10 degrees, right? Which matches the like 15 degrees is about what I get for 2 batteries. So then, if you've done that, then I want you to try this experiment. So you see how I can disconnect, I can take away the light bulb altogether, and I can connect those 2 wires together. By doing that, what I'm doing is I'm shorting my battery. This is extremely bad for your battery, right? If you keep this going like that, it'll burn the battery and the battery holder and the wires, right? So but in the meanwhile, what I want you to see is the amount of deflection you're getting. Let's see. The amount of deflection, let's see, there we are over here, right? So I'm getting close to 60 degrees, right? And I'm going to stop because my wires are getting really hot. So tell me what you see, tell me what you observe. If that fits with what you guys are observing. So what happens if you connect the wires to the battery, but no light bulb? Noel, what do you get?
I'm not completely sure.
Okay. Because
it's kind of hard to tell.
okay. Anybody has some observation they can make? Yeah, Leila?
Well, when I did it without the light bulb, it went almost 90 degrees.
Mm-hmm.
So I think that shows that the light bulb, having the energy run through the light bulb, actually, it like takes a lot from the current, or the current is a lot stronger without the light bulb.
Right. So the current is a lot stronger without the light bulb. So the light bulb is resisting the current. It is called a resistor, right? So you have 2 types of resistors in your, it turns out that the wires are a little bit of like, they're not very good resistors, but they resist a little bit. The light bulb is a better resistor. And then even better than that are the 2 resistors that you should have in your box, the brown and the blue one. But they also resist the current. Clearly, the more resistance to the current, the slower the current is going, the less deflection you're going to see. Okay, so I'm seeing like the deflection depends on the position of the positive and negative charges. If the negative charge is on the south side, then the deflection is clockwise, and if the positive charge is on. So just let's be careful about our vocabulary. It's not so much the positive and negative charges. It's in positive and negative ends, right? Again, the positive charges don't move anywhere. They're all throughout your circuit. The negative charges are the ones that are moving around. And we talk about the positive and negative end of a wire, or the positive and negative end of a light bulb, or whatever, right? Or a battery. Cool. So let's stop that.